At 0502 hours, 5 Ukrainian drones lifted from Cannes, climbing towards this Russian oil storage in Crimea. However, the Ukrainians knew a nearby Zoopark radar opposite from Kherson would detect them instantly. But unknown to the Russians, the Ukrainians had a trick up their sleeve. The first Russian counter-system sat 18 kilometers from the launch site. The detection happened before the drones cleared 50 meters altitude. 5 heat contacts rising from Ukrainian territory set off every alarm in the command post. The operator watched his screen populate with data. Initial velocity 180 meters per second. Climb angle 45 degrees. Acceleration consistent with rocket motors. The Zoopark's computer only needed 3 position fixes, 3 separate radar measurements of where the target was in 3-dimensional space to calculate a ballistic path. First, ping at 100 meters altitude gave location. Second, ping at 300 meters gave velocity. Third, ping at 500 meters gave trajectory. The mathematical model that predicted where artillery shells landed had worked perfectly for decades. Projectile goes up, projectile comes down. Physics does not lie, but Ukrainian drones can. The computer ran the calculation and displayed the answer. 5 HIMARS rockets inbound to grid squares around Chaplinka, impact in 47 seconds. Zoopark's database matched the flight profile steep. Climb specific velocity, 5 simultaneous launches to M31 Glimmers rockets. Ukrainian drones had perfectly mimicked the launch signature of America's most feared artillery system. The operator's pulse quickened as he grabbed the encrypted phone. HIMARS strikes meant precision hits on ammunition dumps, command posts, and fuel depots. The warning went out across 5 different command nets while the countdown timer ran on his screen. 40 seconds, 30, 20, 10, 0. Then nothing. The operator stared at his screen where 5 tracks simply ended mid-flight, 8 kilometers south of launch. The Zoopark radar kept painting that empty sky, searching for targets that were not there anymore. Then it hit him. Those contacts had dove below his radar horizon right after reaching 500 meters altitude. The system could track anything flying above 30 meters over land, but over water, ground clutter and wave returns created a dead zone. These were not ballistic rockets following Newton's laws. They were thinking machines that had used his radar's assumptions against him. The operator switched from ballistic to cruise mode, expanding his search parameters. Ballistic mode assumes targets follow a parabolic arc up then down like thrown rocks. Cruise mode tracks targets that can fly level and change direction. Aircraft, missiles, drones. He had been looking for falling artillery shells when he should have been hunting for flying machines. Last known position 8 kilometers south of launch site, heading 230 degrees magnetic speed before diving approximately 150 kilometers per hour. At that speed, they had covered maybe 10 kilometers while he had been waiting for impacts that never came. He alerted the maritime radar at Armyansk, explaining how the drones had mimicked HIMARS launches perfectly. The Army radar found them 80 kilometers out, skimming waves so low that spray was probably hitting their bellies. 5 contacts in loose formation altitude varying between 20 and 40 meters, like they were terrain following over water. Now came the identification problem that plagued both sides in this drone-saturated war. The radar operator checked the mission database. No Russian drones scheduled through this sector, but the database only updated hourly, and Spetsnaz units often launched without coordinating. These contacts flew the wrong route for returning reconnaissance, heading toward neutral water instead of Russian bases. Their speed matched an Orlan 10, but also matched Ukrainian drones and captured Shaheds. Both sides operated worse. They were radio silent, either autonomous or frequency hopping. Without visual identification or electronic emissions, he could not determine friend from foe. He marked them as unknown, probable, hostile confidence level 60%, and requested fighter investigation from Belbek. The track data got passed to Belbek Air Base with a request for investigation to this Su-30. The Su-30 pilot received the vector at 05:18 hours through his encrypted data link. 5 slow-moving air contacts bearing 240 degrees altitude, 100 meters, investigate and report. The mission brief populated on his multifunction display. Unknown drones, possibly hostile, possibly Russian units returning from reconnaissance. Determine identification before engagement. He pushed the throttles forward and banked west toward the brightening horizon where sea met sky. Finding the drones proved harder than expected. His N011 MBRS radar was a mechanical masterpiece. Its flat plate antenna physically rotating left and right behind the nose cone, 60 degrees each direction twice per second, while transmitting pulses powerful enough to detect a bomber at 140 kilometers. But that power came with assumptions. The radar signal processor expected targets between 1 and 5 meters in size, the cross-section of fighters and cruise missiles. The Ukrainian FP-2 drones presented 0.1 square meters of composite materials that absorbed radar energy instead of reflecting it. At 15 kilometers, where he should have seen them clearly, his screen showed only intermittent contacts that appeared and disappeared like ghosts. He switched to infrared search and track. The basketball-sized sensor under his nose that could spot jet exhaust plumes at 50 kilometers. The IRST scanned in a 60-degree cone, looking for heat against the cool morning background. Nothing. The FP-2's engine ran at 79 degrees Celsius, barely warmer than a car engine, idling invisible against the sea that still held yesterday's warmth. He tried electronic intelligence next. His passive receivers scanning from 0.5 to 18 gigahertz for any transmissions Russian drones usually transmitted on known frequencies. Control uplinks on 900 megahertz video, downlinks on 5.8 gigahertz. These drones were as quiet as a church mouse. The identification problem was about to get worse. At 8 kilometers, he finally got a visual contact through the morning haze, 5 dark shapes against the lighter sea spread across 3 kilometers of airspace. Now, he had to determine if these were friendly or hostile, and he had maybe 30 seconds to decide before they would be out of range. He started running through the identification matrix that had been drilled into every pilot since both sides started operating the same drones. First, check IFFF interrogation. His radar sent out coded pulses asking targets to identify themselves. No response, but most drones did not carry IFFF transponders, the devices that respond. I am friendly to radar queries. They were too small. Second, check flight profile analysis. Speed 150 kilometers per hour matched an Orlan 10, also matched a Shahed 136, also matched dozens of commercial drones. Both sides had modified. Altitude and heading were not conclusive either. They were flying toward Crimea, but not directly at any high-value targets. Final check, visual identification. He needed to get close enough to see markings, serial numbers, any identifying features. But at dawn through the haze, with a closure rate of 400 kilometers per hour minimum, he would have seconds at best. He armed his weapon systems while weighing which one might actually work. The pilot had 3 options, each one sucked for different reasons. His R-73 heat seekers would be perfect if these drones had jet engines instead of a small motor that barely registered above ambient temperature. The R-77 radar-guided missiles could track anything as long as that anything was bigger than a coffee table. These drones were more like flying pizza boxes. That left the GSH-31 cannon, which could fire 1,800 rounds per minute, but required getting within a kilometer for accurate shots. Against drones crawling along at 150 kilometers per hour while he was doing 400 minimum, he would have exactly 1 pass. To identify friend from foe and engage before overshooting. About as likely as threading a needle while riding a motorcycle. Then the secure radio crackled with an encrypted query from ground control asking if he had identified the contacts. He responded negative, requesting guidance. The response took 15 seconds that felt like 15 minutes. Ground control was checking the mission database again, calling different units trying to determine if anyone was flying drones in this sector. While they checked, he watched the 5 contacts continue southeast, now approaching the Ukrainian coast. Every second of delay meant they got closer to whatever their target was if they were hostile, but every rushed engagement risked destroying friendly reconnaissance assets. The order finally came through close for visual identification. Weapons hold, unless hostile intent confirmed. He descended to 200 meters, lining up behind the trailing drone. At this altitude, his engines were burning 100 kilograms of fuel per minute. He had maybe 5 minutes before hitting bingo fuel. The closure rate made everything worse. His minimum sustainable speed was 400 kilometers per hour. The drones flew at 150. He would have exactly 3 seconds from identification range to overshoot. As he closed to 500 meters preparing for the identification pass, his radar warning receiver erupted in alarms. An S-400 battery near YF Pretoria had just locked him up. In the confusion of chasing identified drones, he had forgotten a critical detail. His IFFF transponder was set to standby to avoid alerting the drones. To the S-400 radar, he looked like an unknown fighter escorting a drone strike package. He fumbled for the IFFF switch, but those few seconds of appearing hostile on the S-400 screen had already triggered a response. While he tried to prove he was friendly, the 5 FP-2s continued toward their target, using his predicament as perfect cover. The S-400 operator at Wyptoria had been watching his scope for 12 minutes, tracking the developing situation with growing concern. His 91N6E Big Bird acquisition radar could see everything flying within 600 meters, every transport, every fighter, every helicopter, even large birds during migration season. The system tracked up to 300 targets, simultaneously updating each track every third of a second. He had watched the handoff from Armyansk, monitored the Su-30's vector from Belbek, and now had an increasingly confusing picture developing on his screen. 5 slow-moving contacts that nobody could identify, plus 1 fast mover maneuvering right on top of them. The fast mover's IFFF transponder was not on. No Russian fighter should be flying combat maneuvers without continuous IFFF in their active air defense zone. The geometry looked exactly like Ukrainian tactics from the past year. Drones to bait the defense fighter escort, to protect them when interceptors arrived. The operator's hand hovered over the firing authorization key. S-400 doctrine was clear. Unknown fighters in the engagement zone during active operations were weapons-free targets. But something felt wrong. The fast mover's flight profile matched the Su-30, not a Ukrainian MiG-29 or Su-27. The speed, the turn radius, the altitude changes all suggested Russian aircraft. He queried Belbit control one more time. His fingers tensed over the keyboard. The response came back after 10 eternal seconds. One Su-30 investigating unknown contacts should be transmitting IFFF continuously. Should be, but was not. The operator made his decision based on what he could see, not what should be happening. If that was a Russian Su-30, it would be transmitting IFFF. Since it was not, it probably was not Russian. Probability logic in warfare. Usually right, sometimes catastrophically wrong. He turned his firing key, the launch authority light turned green. 2 Fortyite N-6 DM missiles erupted from vertical launch tubes, 0 to Mach 6 in 20 seconds. One missile tracked toward the slow movers, programmed to detonate in their center to destroy multiple drones with one warhead. The other locked onto the fast mover. The unknown fighter that might be Ukrainian, might be Russian, but definitely was not broadcasting any friendly signals. The missile heading for the drone started having problems immediately. The S-400 was designed when cruise missiles flew at 800 kilometers per hour minimum. Its engagement computer used algorithms refined over decades of testing against high-speed targets. These drones flew at 150 kilometers per hour slower than the missile's minimum tracking velocity. The guidance system kept recalculating intercept geometry, trying to find where subsonic targets would be when a hypersonic missile arrived. It is like trying to use a rifle scope to aim at something right in front of your face. The math just does not scale down. Meanwhile, the second missile bore down on the Su-30 with ruthless efficiency. The pilot had flipped his IFFF switch to continuous broadcast, flooding every frequency with his identification codes. But the Fortyite N-6 DM missile does not have a recall function. Russian designers built it with one purpose: fly to. Target, detonate, delete threat. No abort codes, no self-destruct, no second thoughts. Once that missile left the tube, something was going to go boom. The Su-30 pilot tried every countermeasure in his arsenal, diving toward the water to create multipath interference where radar reflections off the surface confused the seeker, dumping chaff bundles in the specific patterns Russian aircraft use. 8 bursts, 2-second intervals, creating an aluminum cloud 200 meters wide, pumping flares, even though this was a radar-guided missile. Desperation, overriding training, broadcasting emergency codes on the guard frequency that every Russian aircraft monitored. Nothing worked. Russian missiles train against Russian countermeasures every week on the test ranges. The chaff patterns, the flare sequences, the electronic warfare techniques. The missile seeker had seen them all, learned to ignore them all. At 1,000 meters, the pilot pulled the black and yellow handle between his legs. The K-36 DM seat's rocket motor fired, shooting him, and his co-pilot clear of the doomed aircraft. 2 seconds later, the proximity fuse detected the abandoned Su-30 and detonated. The explosion transformed $35 million of sophisticated fighter into a brief orange fireball falling toward the Black Sea. The missile chasing the drones lost track since the radar kept classifying the contacts as biological, and the missile exploded harmlessly in the air. Soon, Russian radio frequencies turned into chaos. Every command level started screaming simultaneously. The S-400 battery commander demanding to know why a fighter was not transmitting IFFF, Belbek Tower coordinating search, rescue the Yevpatoria station, trying to determine if they just destroyed a friendly aircraft. Nobody tracked 5 FP. 2 drones turning east toward Gibardai's depot, now just 35 kilometers from target. The entire Crimean air defense network was paralyzed by the friendly fire incident. Generals yelling at colonels while the real threat flew on unobserved. Well, almost unobserved. The Panzer S-1 crew at Gabardieski Depot had been listening to the radio chaos since 0530, trying to piece together what was happening. Fighters shot down by friendly fire, rescue helicopters launching, unknown contacts still unidentified. They knew something was coming their way, but the radar screen showed empty sky. The Panzer's 1 RS-21E radar could detect aircraft at 36 kilometers, missiles at 20, drones at 15, but only if those targets flew high enough to clear the radar horizon. The first indication came from human senses, not electronic ones. The perimeter guard heard engine noise from the west, a low humming that was getting louder. By the time the Panzer's radar found them, 5 contacts were climbing through 100 meters altitude, 7 kilometers out, 180 seconds from impact. The operator's training kicked in as adrenaline flooded his system. His hands moved across the console, bringing the system from standby to full combat mode in 4 seconds. The Panzer S-1 combined everything needed for point defense in one vehicle. Search radar on top, tracking radar in front 12. Missiles in tubes, 230mm cannons on the sides. It could engage targets from 20 kilometers down to 200 meters altitude, from ground level to 15 kilometers. But it had one critical limitation. The fire control system could only guide 4 missiles simultaneously against 5 incoming drones. The math was unforgiving. The operator launched 257 E-6E missiles at the leading drones. The missiles accelerated to Mach 3, pulling 30 Gs as they curved toward their targets. Each missile carried 20 kilograms of directed fragments that would expand in a lethal cone. The proximity fuses worked perfectly. Both FP-2s took direct hits at 5 kilometers range. Wings separated from fuselages and debris tumbled earth. But that left 3 drones still coming. The surviving FP-2s began their terminal attack profiles. Through their terminal cameras, the tank farm appeared as a grid of white circles against dark ground steel tanks that retained yesterday's heat while the Earth had cooled overnight. The onboard computers selected their targets based on pre-programmed criteria. Tank number 3 sat upwind of the others, perfect for fire spread. Tank number 11 contained aviation fuel, according to intelligence reports, more volatile than diesel. Tank number 18 anchored the depot's northern section. At 2 kilometers range, they dove. Then the Panzer's autocannons engaged both 2 A-38M guns, firing simultaneously 5,000 rounds per minute combined rate of fire. Each tungsten penetrator capable of punching through 20 millimeters of armor. The gunner watched through his optical sight as rounds sparked off one drone's fuselage. Pieces of composite material flying off like confetti. But the FP-2's warhead was armored, designed to survive battle damage. Even with holes through its wings, even with control surfaces gone, the 105-kilogram explosive core remained intact. The damaged drone spiraled down, impacting 200 meters from its target into another tank. The explosion shattered windows across the depot, set off car alarms, knocked unsecured items off the shelves. The other 2 FP-2s continued their dives now at 70-degree angles, nearly vertical. The Panzer's guns tried to track but hit elevation limits. The system could traverse 90 degrees per second horizontally, but only 45 degrees vertically. By the time the guns pointed high enough, the drones had passed through the engagement envelope. At 100 meters altitude, the FP-2s cut their engines and went silent. Gravity alone would carry them to their targets at 50 meters per second. The first drone hit tank number 3 at 0547, punching through the 10mm steel walls like a knife through paper. The warhead detonated in the vapor space where fuel fumes mixed with morning air at exactly the right ratio for maximum explosive effect. The tank did not explode outward. It split at the seams. Like an overripe fruit, 2,500 cubic meters of diesel erupted upward and outward simultaneously, creating a ground-level mushroom cloud that rolled across the depot at 100 meters per second. 8 seconds later, the second FP-2 struck tank number 11. Aviation fuel burns hotter than diesel, and the thermal pulse from this explosion instantly ignited vapors venting from adjacent tanks. Within 4 hours, the depot was gone. Satellite imagery would show complete devastation. 5 tanks destroyed, 3 collapsed, 2 still burning days later. Russian fighters at Belbek and Saki found themselves grounded, not from battle damage, but from lack of fuel. The FP-2s had achieved what missiles could not, eliminated Korean air defense not by destroying aircraft, but by starving them. Bye for now.